Okay. Honorable members and members who are honorable, very warm welcome to my lesson for today, where we are going to revisit the maths introduction. Not only that, but the maths basics. Not only that, but also the rules. So, guys, I think I am ready to get started. Table I've just made you the co-host. Reason for this is in case if my screen disappears, if I'm starting to break, whatever the case may be, you can just unmute and let me know, or otherwise you can just send me a WhatsApp just so that I can attend to that. So guys, I've muted everyone just so that at least I can start this lesson with a very nice prayer, a very short one, and then from there, we will therefore start with some problem solving. So definitely, you might need to be aware that, okay, let me just write down there to say, Maths Masterclass is exactly what we are going to be dealing with. Masterclass, yeah. I'm saying this as if Masterclass say a topic or a subject. Okay, then it's fine. So that means we are going to be looking at everything that is to do with the introduction, the rules, the laws, the basics that are related to maths. But please allow me to start where I always start each time when I have to do this type of a lesson. You say, in mathematics, definitely, we are looking at three things, honorable members: the signs, the numbers, and the letters. You just have to believe me when I say maths is a combination of these things, honorable members. The equal sign, let me just limit it to that. And say in terms of the numbers, it is 0 up to 9. So in between, you'll be having 1, 2, 3, 4, 5, 6, 7, 8, and the last one being 9. What letters do you know? From primary, you do know very well that you've got letters from A up to Z. Doesn't matter if it's capital letters or small letters. So maths, it's a combination of these three things, the honorable members. Very, very much important, that part. The next part of this prayer that I would like for you to be aware of is something called a term. What is a term in mathematics? A term is structured in this format, the honorable member. You've got a sign, which could be a plus or a minus. And then after a sign, you've got a number. If you like, you can say a coefficient. So it doesn't really matter that much. And then what comes after, it is the letter. If you like, you can just say variable. And lastly, we can say an exponent. So this should be the structure of a term. In other words, we are having the sign followed by the coefficient, followed by the letter, and then lastly, the exponent. An example would be something like negative 2k, which means the sign, it is that negative, the number or the coefficient is 2, the variable or letter is k, and then the exponent, it will be invisible 1. So you can see that a combination of all of these things is what I've indicated being numbers, the signs, and the letters. So that means if you are given something like 2x, it could be a squared there that is being added to, maybe let's say y, and we can equate this to, let's say, 7. So you can clearly see that this is a term, this is a term, that is a term. Remember, a term is separated by a sign of a plus or a minus. This sign separates a term, which means this is a term on its own, that is a term, and that is a term being a constant when it's a number. So, interpreting the first term, we have invisible positive. If it's not written a sign, then you know it's invisible positive. That being The number, the letter, the exponent. Here we have a sign being positive, invisible one. There is a letter, and then you've got your invisible one as your exponent. Here, because it's a constant, it's just a number. And that, again, being a sign. So can you see? It simply proves that indeed mathematics is a combination of these three things. So now the last part, just for today, I'm going to be talking about the types of problems. So in mathematics, the honorable members, we mainly have two types of math problems. Those are equations and expressions. Remember, there is a full lesson where I go into details with these things that I'm talking about. But for today, I will just limit it to these so that I can get to the business of the day. So equations, the honorable members, you will always know that you are dealing with an equation if you can see an equal sign. Equation equal sign. So that means with expression, you do not have an equal sign. That is the first thing when you interpret a given math problem. The second part for you to be aware of is that every time when you are having an equation, you must solve. But when you are having an expression, you simplify. Simplify simply means you rewrite whatever that you are given in its simplest form. It's like you're given 2 plus 2 plus 2 plus 2 plus 2. It looks like it's a long thing. It looks like it's a complicated thing. And the simplest form of it is just to add those 2's and you find that is 10. So you've rewritten 2 plus 2 plus 2 plus 2 plus 2 as 10. That is its simplest form. But when it comes to an equation where you have to solve, your final answer must be a letter equals whatever that you are having there, which could possibly be a number. That's how you solve. So it's like solving, we want to know what is the value of the letter, and those letters can only be letter A up to Z. And we are not dealing with any other letters that we do not know. So in most cases in mathematics, they like using letter X. So that's why in most cases we solve for X. Sometimes it could be A, P, it depends on the topic. In finance, we know that maybe I refers to the interest. Something of that nature, the honorable member. So between these two, it is this one that is a bit easier to work with. But this one of equations is a bit tricky in a sense that we've got different types of equations. Maybe let me name two for now. We've got what we call a linear equation. And then we also have what we call a quadratic equation. How do you know that you've got a linear equation? That's if definitely there must be an equal sign because it's an equation. So there must be an equal sign. And then you might be having the letters there, maybe plus 2 there, and then here let's have K. So when you look at your equation and you analyze the exponents on every letter, you can see that we have exponent of invisible 1. So the highest exponent is 1. For that reason, it is therefore a linear equation. But when it comes to a quadratic equation, you might find that you are having 2, maybe we plus it with p squared, maybe let's equate this to x, and then we plus it with maybe j. Yes. So now you do your inspection to say, on the given letters, what is the highest exponent is 2. When the highest exponent is 2, it is therefore a quadratic equation. So the exponent tells you how many final answers you should be having. If the exponent is 1, we know it's linear. So that means you will have only one possible answer, which means you will say one letter equals to whatever that you are having. For now, let me just say a number. But if it is a quadratic, it will therefore mean you will have two possible answers. That two, it means two possible answers. For example, if you had to solve for P, then it means you will have P is equals to whatever number, that's why you will end up saying or otherwise, if it is N, doesn't really matter that much, then you will still say P again is equals to whatever the case may be. So that means if the highest exponent was 3, it would mean you were going to have 3 possible answers. If it was 4, 4 possible, 5, 5, 6, 7, 8, and so on and so forth and stuff like that. I hope that part makes sense. So this is the prayer that I was talking about, the honorable members, to say, as a mathematician, you should be in a better position to understand all that I've explained. Worry not in case if not everything makes sense, because as we start dealing with the problems, things are now going to start making some more sense. But for now, I will just end it there with regards to that mini prayer and say, Amen. So let me check if there are some of you guys who've got some questions for me in relation to that prayer. Let's see. So I'm telling you, honorable members, just before you eat, you can just temporarily forget about may God bless our food before we eat. Amen. Just try pray this prayer, the honorable. I'm telling you, you are definitely going far with this one. Okay, let's see, guys. Anyone who's got a question based on what I've explained up to this point, or are you ready for the problem solving, which is something that I'm going to do on your side? You'll just be watching. Do not worry about taking some notes, because yes, this is definitely recording. As soon as it is done, I will make it available to everyone, and I will let you know in terms of where you can access it. But anyone who's got a question based on what I've explained up to this point, or everything made sense?
Everything made sense, sir.
Langlish confirmed, you say all made sense. Anyone to confirm? Last one to confirm.
Everything made sense.
Everything made sense. Okay, then it's fine. Let me mute all and say no. I've just mute everyone. Then now I will continue. To move at the speed of light, I wanted to say I'm going to speed. I really want to say that. I'm not sure. But anyway, it's fine. I'm going to be moving at the speed of light. So in mathematics, we don't waste time. And with this type of a lesson where we are doing introduction, definitely the honorable member, you have to move at the speed of light, because some of these things are not necessarily that much complicated. Let me just get these problems ready so that I will start dealing with them one by one. Okay, so now this is my first problem. Let's say I'm having that, and then I will plus it with that, and then equate it to that. So this is what happens. As a mathematician, you look at this, you see an equal sign. Then you will say, okay, this is an equation. Why? Because it has an equal sign. What type of an equation is this? Is it a linear or is it a quadratic? Because x is to the power of invisible 1, it is therefore a linear equation, which means I'm going to have one possible answer. For that reason, with me solving this type of a problem, it means I must take all the numbers to one side, all the letters to one side. So everything that is attached to a letter, I leave it on the left. Everything that is a constant or a number, I take it to the right. That's all that I'm going to be doing for the next 10 problems that I'm going to be solving. For all of them, I'm not going to interpret them in this way, but I will just be solving them. So I'm about to start now. I will see how fast I can be able. So in case if I make a mistake, please leave it as it is, the honorable member. For now, it will just be my mistake. In the end, we will revisit these things to check if I've made any mistakes or not. And most importantly, just be aware that I can make mistakes, you can make mistakes. It's just a matter of, are you able to notice when you are making a mistake? And also, I will try to be fast so that you can be able to notice what contribute towards one making a mistake. I know someone has worked it already, but let me start. Okay, so this one is attached to a letter. I'll leave it on the left. Already this one is on the right. This one becomes a visitor. It changes the sign. And then I will have to simplify these things on the left. That minus that definitely is that. So now I want to remove this 3. The only way to remove is to divide it by whatever on the left, do the same on the right. That into that, it goes 5 times. And that should be the end of it without me having to use a calculator. So very quickly, I'll jump on to the next one. Not that much complicated. Okay, this one I'll leave it on the left, and then that goes to the other side, becomes a visitor. Then now that plus that, I think it has to be that. Now I need to remove that 2 so that it cancels, and then I have a letter. It's equals to a number. Then it's done. Remember, I'm on linear problems. Okay, what's happening here? I'm having this, and I'm having that where we minus that, which is equals to that. I've got 2 ways in which I can deal with this one, honorable members. The first way to deal with it is to remove the bracket where I do that by that, that by that, even though it may be a long drive. But let's see, because I'll end up having 5x where I minus 10 and that being equals to 20, whereby I will leave this and then that becomes a visitor on the other side. And then working that with that, it gives that, whereby if you remove that 5, you end up having what? Is it 6? Let me just say 6 because I'm not using a calculator. And then the other way in which you can work it out, it is to actually remove that 5. How do you remove it? The only way to remove it, it is to divide both sides by that 5 so that you can remove it. So that and that, and then you end up having that minus that, which is, what is that? I think that is 4. Definitely, letters one side, numbers one side. It becomes a visitor, then you end up having that. So these are the 2 possible ways in which you can work it out. Okay, now very quickly moving on to the other one. This is what I'm having. Then we plus it with that. Remember, it is an equation because I see equal sign. So since it is a linear equation, because I'm having invisible 1 and visible 1, for that reason it's a linear equation, which means I must have one side having the letters, the other being the numbers. So everything that is attached to a letter, I put it on the left. In other words, each term that has a letter, put it on the left. So that means I'm going to have that. That one goes to the other side, it becomes a visitor, it must change the currency. 11 is already there. That's why I start writing 11 on the right hand side so that it is clear that the 3 which changes the sign, it is the one being the visitor. That and that, what will that be? Is it 8? I think it's 8. Then now I need to remove that 2. Then that equals to 4. Bese o tetele. Hope you fully understand what that means. Okay, so now let's see. What if I'm having this, which is equals to that I plus it with that. So this is x. Then taking this to the other side, it will therefore be that. Here you minus that 2x. Definitely that is already there, and then that. This, what will that be? I think it will be 5x. That will be 15. I need to remove that. Then that becomes 3. Something of this nature, the honorable member. So maybe let's have a look at a situation where now we are having let's say a fraction. Maybe we are having that and that we plus it by that, which will be equals to that. Please do not panic, the honorable member. Just be aware that each time you have a letter as the numerator and a number as the denominator, you have something there being 1. If there is nothing, just know that it is 1. So in other words, this thing, if you do not want to confuse yourself, just take it as 1 over 3x, where it is being added to 4 and that being equated to 10, just so that you do not confuse yourself. Then from there, you will therefore say every term that is attached to a letter, it will therefore remain on the left-hand side. So that means you are having 1 over 3x, this being equals to, and that being the visit. So that means you are having 1 over 3x, which is, what is that minus that? Is it not 6? I think that is 6. So now, what else can you do? What you know is that you just want to remove or detach anything that is attached to the letter being x. That is why you will divide both sides by that 1 over 3. So that cancels with that. And then you end up having, trust me when I say, if you punch that on your calculator, it might give you 18. For now, let's just assume that it is 18. We'll therefore continue with it. So guys, please be aware that this is the beginning of mathematics. With you being in grade, doesn't matter whether you are in grade 10, 11, or 12, even if you're in grade 8 or 9, it doesn't really matter, the honorable member. All that I'm doing now, you will forever be doing this. It's just that it's being asked to you differently. So the reason why I ended up becoming good in mathematics is because when I was in, I think, grade 12, I had to do or redo all the grades while I was in grade 12, because I could realize that many honorable members were struggling in grade from 10, 11, and 12, and they thought that's where their problems are, until I discovered that actually most of the honorable members think that because they are in the highest grade, it could be 11 or 10, 12, then they think that's where their problems are. But that is not where the problems are, the honorable members. That's why when you get to grade 11, you do most of the things. When you get to grade 12, it's just a few new topics being added, but the others is all that you have been doing in your lower grades. And then from there, you might find that in March, you could be done with your grade 12. All that you do is just a revision. So in case if you are in your highest grades and you're struggling, this is where you need to start and redo all of these things. Make sure that your foundations are solid. Trust me when I say, even if there is a problematic problem, you will easily understand when it is being explained. You won't have an issue of not understanding what the topic is all about, and struggling with the calculation itself, which is what I'm doing now. Okay, maybe let me continue and see how far I can go. Let's say this is now, maybe let's make it a minus there. Okay, this is what you are having. What I know is that BODMAS says you must start with where you are having the brackets. In mathematics, if you get to a situation where you don't know where to start in dealing with an equation, always look for the brackets. That's where you start. It is always easier because you do that by that, that by that. Just be aware that a number never multiplies a letter. Listen very carefully. A number never multiplies a letter. Remember when I started, I said we've got three things: the signs, the numbers, and the letters. So the sign will always multiply a sign. The number will always multiply a number. The letter will always multiply a letter. Just keep it simple in that way. So that means this 2, which is on the outside, when I say that by that, the 2 does not multiply the x. It multiplies a number, which is invisible 1. The sign, the honorable member, which is invisible positive there, it doesn't multiply the 1, it doesn't multiply the x, but it multiplies that invisible 1, which is, invisible positive, which is there. So in other words, as a mathematician, you need to say a positive times a positive, it is positive. Then you leave it as that invisible positive. I'll write it there. Then a number being 2, it multiplies a number being 1. What is 1 times 2? Is 2. So you do not have a letter that multiplies with that. So that's why you will just leave it as that. But if, for example, you had a letter there, then when multiplying the letters, if they're the same, you add their exponents. If they are not the same, you just attach them in case if it was y there. That's how you interpret mathematics on. Okay, so Positive sign times positive sign, we know it's positive. A number being 2 multiplied by that, we know it is 6. And then here, same thing. That by that, it is the positive by that positive being positive, the number being 3 multiplies 1, which is 3. And then we have a letter, we just attach it. And then what is positive times negative? We know it's negative. If you are multiplying different signs, they will always be negative. But if they are the same, they will be a positive. We are talking about the positive multiplying a positive being a positive. A positive multiplying a negative will therefore be negative. But if it's negative multiplying negative, it's positive. That's what I'm saying. If they're the same, positive. If they're different, okay. Hope you get it. Then 3 times 1 is that. Then we are back to all those problems that I was doing where I say you need to take something to the others. Okay, now let's see. You are having that 2x where you minus that 3x here. It is negative. Now you minus that being a v. So trust me when I say it is positive 2 where you minus a bigger number, you end up having negative invisible 1x, which is equal. What is that and that? Is it not negative 9? It's negative 9. So now you are forced to divide by negative 1. Why? Because you need to remove that invisible 1. That's why if it is just negative x, you always divide it by negative 1. Why negative 1? Because you know there is an invisible negative 1 there. Then it cancels negative and negative that, and then that into that, you are having a that. So maybe let me try and find something a bit different and say that being divided by that, and then you are having that. Okay, so this is what happens, honorable members. If you are having a fraction, if you are having a fraction on the left-hand side, I'm not sure if it's the correct mathematical ways to say, but fractionalize the other side. In other words, force it to be a fraction. So that means that 3, you will force it to be a fraction, say over 1. You always say over 1 so that you can cross multiply. That multiplying the whole of that and that multiplying that. You just need to be careful there to say that 1, it actually multiplies the whole of that. That's why I have to do it that way. And then these two terms, they can just nicely multiply. Now we are back to that by that. Then it takes you back to that, which is 15 there. You are having that. And then that on the other side, it becomes a visitor. It's better to just write it, even though I know it is 16, just so that as I do this, it will therefore make sense to say x is equals to 8. And that should be the end of it. Maybe let me do one more, then I should be done with the linear equations. I will therefore be jumping onto something else. So now, let's see. Okay, let's say this is what we are having. You are having 3, maybe let's say into that, and then we plus it by that. Maybe let's minus 4 there. Why not equate it to 2x? Maybe to make it even nicer, let's just plus a 5 there. Where do we start? Okay, what is this? This is a maths problem. What type of a maths problem is this? It's an equation. Why? Because I see an equal sign. Okay, then what type of an equation is this? Is it a linear equation or is it a quadratic equation? Looking at the exponents, it looks like I'm just having invisible 1. For that reason, it makes it a linear equation. Therefore, my final answer will be 1 letter equals a number. But the question now is, where do I start in solving this problem? I have to start by removing the brackets. How do I do that? That by that, that by that. That is your starting point. Then you have 3x, that by definitely 6. Then you will have to minus that, then you are still having all of that. So now can you see it's just a matter of you taking things to the other side. Definitely, this one you will leave it here. When you work out that, I think you can just simplify it to 2, and then definitely this is what, maybe let us one side. So I am forced to transpose or transport that. Okay, that one has to become a visitor on the other. This minus, definitely it will be, what is 5 minus? Even a primary learner will tell you that 5 minus 2, it is equivalent to 3. Bese uqedile, the honorable member. Trust me when I say, if I wasn't speaking before the end of a second, I would have finished with all these things, the honorable members. So now I'm just going to invite some questions in case if there are any. Otherwise, if not, I will therefore continue accordingly. Remember, guys, this lesson is meant for the honorable members who are struggling in mathematics, not those who are performing well, because definitely you are going to be bored with this kind of things, especially that you might have dealt with them in beginning of the year. But let's see, any questions, honorable members, something that I explained which did not make sense and you would like me to clarify further? Or did everything make sense? Bandla kaNkulunkulu.
Everything made sense, sir.
Are you sure?
Yes, sir.
Okay. Imivuyo, are you sure the honorable member, Natasha? I'm just trying to find. Okay, there's Natasha and there's Tina. Okay, HTTP unknown. So Miller, guys, everything made sense. Remember, this is being recorded. So that means you will definitely have an opportunity to revisit these and be able to try and redo these exact problems that I have done. Okay, then it's fine. So now I'm just going to mute you all and I'm going to get into a very problematic mute all. Yes, this is actually what I wanted to do. I'm just wondering if I should get into this one or maybe not yet now. Maybe not yet now. Maybe not yet now. I'm just waiting for this to save. Then as soon as it's done, I will therefore take you through what I've... Okay, I think we are ready now. So we've just done equations. There are more types of equations which you might need to deal with. But for now, let me try and take you through some problems involving the fractions. Maybe let us start it here and say, with you having that, maybe let's plus x and let's divide this by y. Yes, something of this nature, the honorable member. You look at these, then you realize that, okay, actually, this thing, it's not an equation because I don't see an equal sign. What could it be? It has to be an expression because it is not an equation. For that reason, you will have to simplify. Maybe for me to be practical, let me try and do this. Maybe not that. Imagine you are having a half that you plus it by a half. What is 1 over 2 plus 1 over 2? As 1 over 2 plus 1 over 2, it may sound a bit challenging for you to come up with the final answer, but simply half plus half. Half of a loaf plus half of a loaf equals 1 loaf. So that means half plus half is equals to 1. But let us prove it mathematically. This is what I'm going to therefore teach you, because if you can master this, you will therefore be able to deal with any math problem that has to do with simplification where fractions are involved. How do you do it? Okay, let's say our lowest common multiple, or maybe LCD. Doesn't really matter that much. For me, I never worry that much about all of this because I just know that all that I do is to take the denominators. So that means what I do, it is to take these denominators as they are. So that would be your LCD, which means your LCD would be those two denominators as they are. And then what you do is to multiply each fraction by this thing. So that means you will therefore take that 2 and that 2, and you multiply that 1 over 2, which is added to. Again, you multiply each fraction by that LCD of yours, so that you can see this 2 cancels with that 1. Then it's like you're having 2 times 1, which is what? Which is 2. That you will plus it with. And then this 2 cancels with that 1. What is 2 times 2? Definitely, that is 2. That you divide it by this 2 and 2. Wait, what is 2 plus 2? Is it not 4? What is 2 times 2? Is it not 4? It's 4. What is 4 over 4? 4 over 4 is 1. So that's how you mathematically prove that a half and a half equals 1. So now let's try and use this same principle to work out this one. So what I said was that means your LCD in this case would be this 2 and that y. Maybe before I write it in that way, it doesn't matter if you put the 2 inside the bracket and the 1 inside the bracket. At the end of the day, it's like you're having 2 times that, which ends up being that. So it doesn't really matter that much. It's fine. I will therefore just do it this way, just so that I can remain consistent. Then what did I say? This LCD, you multiply each fraction. So that means that 2 and y, you will therefore multiply that 1 over 2 plus, again, that 2 and that y will therefore multiply that x over y. Just so that the 2 can cancel with that 2, it's like you're having that times that, which is just that, plus the y cancels with that 1, 2 times x, it ends up being just 2x divided by that times that, you end up having just that. And this should be the end of it, the honorable member. Trust me when I say I'm going to call 10 triple 1. If you start now to divide that, you can't, the honorable member, you just can't divide that by that. Why? Because you are having a sign of a plus or a minus. The moment you are having a sign of a plus or a minus, you just can't cancel out those things. You can't cancel this and that. The reason why I'm emphasizing this is because that's where most of you guys make a mistake. Okay, then it's fine. Let's try and do a different problem. Let's just try and prove this one. Please punch this on your calculator. Punch 1 over 2, let's say plus 1 over 3 plus 2 over what? If we make it 4. Yeah, it's fine. Let's make it 4. Can someone please punch all of this on your calculator? Whatever that it gives you, please write it down. On my side, I will try to mathematically work it out following that method that I've just shown you until I get it. So that means I would say the LCD will therefore, based on my explanation, it should be that. So based on what I explained, you now have to have your 2, your 3, and then your 4. And then you will have to multiply everything by that. So that means it is actually, you can just say, maybe let's say 2 for the sake of space, because if I do the multiplication thing or the brackets, it takes too much of space. but always use the brackets. Don't do it that way that I'm doing it. Because it will end up looking like it's a comma, whereas it's a multiplication in between. You put a dot if you are having the letters, but if it's just the numbers, you use a normal multiplication. For me, I will just use this for today because of space. So that one being 2 over where is it? 3 there. It is not that, but it's that. Yes. I'm suspecting that when you punch this on a calculator, it will be what is it? 1, 3. That's what I'm suspecting that it gives you on a calculator. In case if it gives you that 1, just convert it to a fraction. Because my final answer will be in a form of a fraction. I'm not a calculator, can only be a fraction. So, okay, now let's see. You see now you are having that cancelling with that. So that means you're having 2 times 4 times 1, not 2, but 3 times 4 times 1. That's what you are having. Plus, this 3 cancels with that one. Then you're just having 2 multiplying the 4, multiplying the 1. This 4 cancels with that one. Then you're just having 2 multiplying 3, multiplying 2. The whole of that being divided by that times that times that. I think we can already work it out. Let's see. What is 3 times 4 is 12. 12 times 2, 1, 12, 1, 4, 2, 4 is 24. Okay, so now what is that times that? Definitely it is 12 times 1 is 12, plus that times that, it is 8 times 1 is that. That times that, it is 4 times 3, it is 12. And you are having 12 over that 24. And then you are having, what is 12 plus 12? It is 24. When you plus it by that, it makes it 32. Is it going to be 32? Maybe 32 over 24. Yes. Something of this nature, the honorable member. So as a mathematician, in case if you are dealing with bigger numbers, you can do something like, will it be 2 times 15 or 16? I mean 32. Is it not that? What about 24? Is it not that times that? And then that cancels with that. Then it's like you're having 16 over 12. I'm just hoping that what I'm doing there is correct. So what about 16? I think 16 is 4 times 4. Yes. What about 12? It's 4 times 3. Yes, I think so. And then that cancels with that. You end up having 4 over 3. Guys, maybe let me ask you, Deputy Speaker. Tebogo, did you punch it on your calculator and did it end up giving you that, or did I get it wrong? Because yeah, these things can be moving sometimes. Let's see. Why is it like Deputy Speaker is sleeping in Parliament?
No, sir, I'm not sleeping.
Yes. Did you punch it on your calculator? What did you get? Did I get Murt or did I Murit?
You moved it, sir.
Are you sure?
Yes, sir.
Let's see. Members of Parliament, is the honorable member correct there that I moved it, or did I get moved? Or is it you who got moved? Lungile Mabina. In school, they say Lungile Mabina. Lungile Mabena. Guys, did you see what I've done there?
Answer is correct.
Pumeza?
Your answer is correct, sir.
The answer is correct. Okay, then it's fine. That's what I wanted someone to confirm. Remember, guys, it might look like I'm moving at a speed of light trust me when I say it is on purpose. The reason for that is because I am recording this. You can be able to visit it at a later stage in order to try and redo this exact problems that I'm doing. Then the same answers. So this one that I've done, it was comprising of the numbers only. So that means even if it has different letters, you just follow the same principle and work it out in that same manner. So it's fine. I'm just going to now add one where I'm having, some letters. So on the next masterclass, I think I will therefore be going deeper, the honorable member. So that means you just need to make sure that if there are some parts of this lesson that you did not capture, you just have to make sure that you drop me a WhatsApp text after this and request the location of where you are going to find this recording. I'm just trying to think of where I'm going to put this, but it's fine. It's fine. It's fine. It's fine. Okay. So let's say for some reason you are now having X. It could be over 2 that is being added to maybe 1 over 3 where we minus. Doesn't really matter that much. If perhaps we say P over, it could be K there. Really doesn't matter that much. All that you know is that this is not an equation, but it's an expression. The only thing that you can do is just to simplify. Where are you going to start? You can still start with that thing of saying your LCD there. Definitely, you know that it has to be 2, it has to be 3, it has to be K. So that means you will have this big line where you will have your 2 there, your 3 there, and then your K. Guys, please trust me when I say you will never realize as you are doing maths that actually these are the same things that I'm doing. It's just that now they are being given some names. Some of them are profits, some of them are interests, some of them it is the annual or the period that you are calculating. But you just follow this same principle when dealing with the fractions. So very, very much important, the honorable member, that you do not take this lessons lightly. And most importantly, remember that this is not necessarily a replacement of what you should be doing on a daily basis, but it is meant to actually add on to that so that you will better your understanding. That's supposed to be a minus. If I kept on it with a positive, it would have been wrong, because it's like they are giving you a question in this format and you change it because you've practiced that same problem where it had a negative. So it's like now you are giving your own question to solve. Okay, so now this 2 cancels with that. That's a straightforward one. And then now you have 3kx. So you write them to say letter between k and x, which letter comes first is k, and then after is x. That's why you will write it that way. The 3 cancels with that. Then you're having 2k1. And then 1 times 2, it is definitely 2, and then the letter being k. Then the k cancelling with the k, then you're having 2, 3p. 2 multiplying that definitely is 6, and then having the letter P. And you divide the whole of that by that, definitely that, and that. It will be 6. And then it is been multiplying with that. Then you leave it here, the honorable member, because you just can't cancel that with that. The moment you do that, I'm telling you, I'm going to call 10,111 the honorable members. I am going to call 10,111 the moment you do that, because you cannot cancel the moment you are having a sign of a plus or a minus, either at the top or at the bottom. In other words, if you are having k that is being divided by 1 plus k, you can't cancel that with that because you are having that. Please, honorable members or members who are honorable, please, 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 please Just do not do that. I think since today it has been about the fractions, maybe for the remaining time, being about 6 minutes, let me just squeeze in some fractional equations or equations in a form of fractions. Maybe let me start here and say, now if you are having this which equals to that, you see now it is a fraction, but in this case it's not an expression. How do you do this? You force it to be a fraction on the other side, just so that you can cross multiply, which means the one with the x and then the number with the number being 2 times that, which is 8. And that is the end of it. So now let's look at the second one. Maybe you are having that. I think this one I've done it, even though not exactly this, but I said you are having that, which is, what is that minus that? Definitely it will be 3 on the other side. You see, now I'm taking shortcuts, but remember,
Guys, Sir said he's gonna like rejoin. He's having nkingas with his network. Katlhaloganya. Yeah.
boom, 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 boom. Okay, 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 okay. The honorable member did notify me to say you were no longer audible, and it was definitely because of my network. Okay, Deputy Speaker, how about now? Is it fine now, the honorable member? Am I audible?
Yes, sir.
Okay, then it's fine. I'm not really sure in terms of where I lost you guys, but seeing that it's almost time up, I think we might as well leave it here. But perhaps before I run away, just give you guys an opportunity to ask any questions related to all that we have covered today. And also, this question will then be directed to those who are really struggling to comment in case if there might be a need from time to time to have this type of lessons But let's see, guys. Any questions, comment on your side before I run away? Singabalega manch. Singabalega manch. Guys. Fezeka imivuyo khanya Koumani Lungile Mabina Nate Hosha Pumeza Mgwadliga So Miller and Nashi. I know deputy speaker should be sorted. Guys, any questions, comments, or do you guys allow me to run away?
Nah, no questions.
No questions. But wait, guys, are you sure that you just don't want to speak too much English in your home? And you just say no question, just so that your parents can think you understand the and that time you are not understanding a thing. Guys, Tebogo. Apeka mokgo ba ra gore ke tsamaye monna ene nna ke senye nako ke a tsamaya ape monna
No questions, sir.
ke a zaya jwale